Hey everyone, in part one of Project Overkill, we went through and made all of our cables and we mounted our bus bars and fuses to this plexiglass plate. We now have our inverter mounted on the wall and we are ready to start running all of the inverter cabling. We're also going to use these surge protectors. We're going to cut these ends off and wire these directly into the terminal block. These have a built-in circuit breaker, so that should work out really well. Say like 18 different ways and then just make it work. You may notice that we have two separate pieces of wood here, and that is so if we decide to do a second inverter, we're just going to replicate whatever we do on this top board down here on the bottom board. So for mounting these pieces of wood onto the wall, we actually went through and found the studs behind the wall, and then we used these RSS rugged structural screws. These are 5/16 by 3 1/8 inch, and they look like this. I have not been responsible for this kind of stuff. I do like the electrical side of things, and my father-in-law's been taking care of like the wood and all of this kind of stuff. In typical fashion, these are overkill as well. So the 5/16 by 3 1/8 inch is good for 840, and this says pounds F, so I'm guessing that's pound feet, and that's energy absorbed for like impact strength and shear strength. But either way, these inverters weigh like 60 pounds tops. And we have 6 of these in each one of the pieces of wood. So I think we would actually have to rip the studs out of the concrete before these things are going to let go of these inverters. And then, as if that's not enough, we actually ran these through the mounting holes of the inverter, top and bottom, into the stud in the middle here. So the pieces of wood are held on by 6 of these screws, and then the inverters themselves have 2 of those mounting screws into the stud. I think it's going to be okay. So when we end up with a second inverter down here, we're going to have 4 3/0 cables running on this side here. So to try and make the cable management as clean as possible, I got on Blender and designed these cable clamps, I guess you would call them. I put 3mm holes here, and then these just fit together like this. And I went through and designed a 4-wire, a 3-wire, a 2-wire, and a single wire. Because as we go down this, these 4 wires will be used for the 90-degree angle right here. And then once this negative comes in here, it's going to drop to 3 wires here. And then down here is going to be just the 2 wires for the bottom inverter. And then it'll drop to the 1 wire after this negative for the second inverter comes off. And it'll just be that positive wire. So I want to keep these as straight as possible. And the only way to do that is to really hold them in place with these clamps. Alright, so now we're ready to start making the 3/0 wire for our positive and negative on this inverter. Then positive is going to run down and around to this fuse block here. And then the negative is going to run to the very back onto the bus bar in the back. We have our first 2 positive and negative cables ran, so that'll be powering this inverter. And then in the future, like I said, I have 2 extra spots here for the next inverter down. Now we're ready to mount our surge protector. So that's going to end up coming in down here, just like this. This will wrap around and this will mount into our terminal block on this side here. Now we have our surge protector mounted with Velcro. This isn't going to go anywhere. And the wiring is ran out and actually behind the inverter. And then over here you can see we have a green, black, and white wire, and I checked continuity on this already. And the black is the hot wire, the green is our ground, and the white is neutral. So now we're going to wire this into the terminal block. Now we have our surge protector wired into our terminal block. This is our ground, as you can see by this symbol. And then you can't really see behind this white wire, there's an L for where this black wire is going in. And then you can see the N right here for the neutral. So we have all these wired up. We should be good to go and ready to try this out. All right, guys, everything's wired up. I am still waiting on BMSs, but I'm gonna hook some batteries up and try this out. I can't resist. I'm gonna disconnect all of these except for one set. So there's only gonna be one set of positive and negative wires that are gonna run to our bus bars and everything, but I wanna try this out and do a little bit of load testing and see how this thing handles it. Okay, so I went through and wired 2 of these batteries in series. We have our main negative here, and then we have our main positive on this end. These run up. These are the only 2 wires that are electrically connected. All of the other wires right now are disconnected. We should be ready to turn this on. It's doing stuff. Alright, so we have a green light here, inverter power online, battery charger off, green light here, so there's no alarms. So that's always good. And let's turn on our surge protector. Alright, so we have power there. I have a dehumidifier down here. I'm going to go ahead and turn that on, and then I'm going to clamp my clamp meter on here and see what kind of amperage we're drawing from the batteries. So the compressor and the dehumidifier just kicked on. You can see we're drawing 14 amps from the batteries right now. And this actually, the screen here, I know you can't see it, I'll get a little bit clearer of a shot later in the video, but it has a load indicator here. And it says we're at 22% load. So that's kind of handy if you just want a quick reference for, you know, how much more power do you have available based on what this inverter can supply. You know you're at 22% right now, plenty of power left. Yeah, that sounds dumb. So here's a better shot of that screen. So it'll show you the voltage of the batteries. It says welcome, that's always kind. AC abnormal is because we do not have any shore power hooked up. And then output power is 121 volts, 60 hertz, and load is at 21%. And then it goes back to the battery voltage. So it'll just keep looping that over and over as long as the inverter is on. Alright, now I have this 1500 watt heat gun. And I'm going to plug this into the surge protector also and see what happens. Okay, still at 13 amps on the draw there. Let's go ahead and turn this on high, because why do low? We're at right around 53 amps that we're drawing from the batteries right now. And our screen over here, the fans in the inverter kicked on, that must be load based. 78% load. Battery's at 46 volts. So you can hear the fan back there right now. This should shut off in a moment. Alright everyone, we got our inverter cabling ran, we got our surge protector mounted, and we did a quick load test to make sure everything was working properly. And I'm going to call it quits right here on this video. So I hope you enjoyed. Thank you all for watching, and I'll see you on the next one.